So, good day everyone. I am Jamaica Mañabo and my partner is Vanessa Joy Bardago. So, this video is about how to use ComBase. This is a tutorial video, our final PIT in food microbiology. We are from BSFT to M1. So, this is Vanessa Joy Bardago and this is me, Jamaica Mañabo. So the contents are the steps on how to use ComBase. So first step, to begin, we display examples from the tens of thousands of records that make up the core of the database. It is a system called ComBase. A browser can access this database from the ComBase homepage. By clicking the arrow in the box, select Listeria from the pull-down choice for the sample organism. So here is the chart which you can select bacteria. Uh, You have a variety of possibilities as well as selecting more creatures you can. So adding another field is simple as clicking add another field, select the food matrix you're interested in as well as additional bacterial environmental factors response. So the static or dynamic options indicate whether the environmental changes are static or dynamic. During the observation, circumstances, mainly temperature, pH, and water activity were observed. In this case, we'd like to know what data there is on Listeria and E. coli in cheese or milk. The temperature of the culture media was constant, static, between 0 and 15 Celsius during the experiment observation. So, as I said earlier, this is where you're going to search or where you're going to collect to choose what bacteria you are interested with. So select search from the drop down menu on the left side. Moreover, 3,700 records satisfy the query according to the resultant screen. Pages are used to display the returned records with each page holding 10 records. Page 1 out of 370 begins with the low temperature data followed by extracts of accessible data for each record and a summary of the findings as log count, V time, a little plot on the answer. Next, step 2. So if the plot on the output screen shows a straight line, then the available response is the growth death rate, represented by the slope of the line. If the line is horizontal, then no significant change was detected in the log cell concentration during the observation time. Take note of the question mark sign as well as the export button, which allows you to export the data to another location. CSV files can be used for further analysis. Step 3. Log count measurements were taken if the graphic shows points. If this is the case, you might want to make your own fast estimate of the growth or death rate. You can do so by hovering your mouse over the heading of analyzing the data and deciding on a suited strategy. Next step, step 4. You can also make a comparison between the data and the forecasts. It's worth noting that the projections are based on data collected on the best possible culture medium. These records are also in the ComBase database, with approximately 2,500 records for the approximately 30 models. This screen, which uses slides to represent various environmental parameters, allows users to assess how much environmental change would result in the expected rate and lag, a depiction of the prediction's confidence. So this is the chart. Step 5. This leads to a case study showcasing the usage of the ComBase, the other main tool. So, Predictor is a tool that may be found in the navigation menu. Select Listeria once more and compare their growth rate at 8 and 13 degrees Celsius. You may determine that a 4 degrees Celsius in storage temperature may have the growth rate. So assuming the other parameters pH and AW are all appropriate. So here's the chart. Last step, for the step 6. So determine the amount of salt that would result in the same drop in growth rate as an exercise. To rescale the humectant slide, click the NaCl button or sodium chloride button and set it such that the lower predictions cover each other. Under these circumstances, 6% sodium chloride could have the same inhibitory impact as a 4-degree lower temperature. The water activity, the water activity sodium chloride conversation proposes that sodium chloride is dissolved in water. Hence, it is not always valid in food. Even unsalted food can have very little water activity, according to the AW measure. Example, other humectant is added or the food got dried. Notice how we click on the upper left corner of the window, keeping only the menu symbols that the text visible, allowing more room of the figure. So here it is. That's all. Thank you.